Okay, so this session is about X and Y intercepts. And while what I'm going to be doing today is focused towards specifically linear equations and lines, when you get to functions next week, and if you have to go on to college algebra and you have to find X and Y intercepts, the same rules apply even if the graphs look different and aren't lines, like if they are curves or other sorts of shapes. So what exactly are intercepts? So when we graph equations on our 2D graph on our coordinate plane, a lot of times your line or whatever you're graphing is going to intersect the X and Y axis. And where those intersections occur, those are what we call intercepts. So a linear equation has two intercepts. So if I was to draw my XY plane or my coordinate plane here, a linear equation, it's usually slanted, and so it's going to intersect the x-axis at two locations. Or the x-axis at one location, the y-axis at one location. So there's two intercepts, one for each. There are some special cases, horizontal and vertical lines, where there will be one intercept but not the other. So like a horizontal line will only cross the y and there will be no x-intercept. Intercept. And a vertical line only crosses the x and has no y-intercept. So as long as it's not vertical or horizontal, your line is going to have two. It's going to have an x and it's going to have a y. So the specific definition of an x-intercept is that at some point a comma 0, so that y value is 0, and that's where your graph intersects the x-axis. So to find the x-intercept, you replace y with 0 and then you solve for x, because y is equal to 0 at that point. It's very similar for the y-intercept, so that's 0 comma b, so the x value is 0. So when you're finding the y-intercept, you replace x with 0 and then you solve for y. So they're very, very similar on what you do in order to get an x-intercept and a y-intercept. It's just a matter of knowing, do I plug in y as 0 or x as 0? So if you're finding the x, y is 0. If you're finding the y, x is 0. So kind of think about how it's like the opposite, because you want the other variable to disappear. So we'll start with just looking at graphs and then estimating where the x and y intercepts are, so you get used to seeing it in a graphical form, and then we'll have equations and we'll find them that way. And then what's really nice is that with equations, if you find your x and y intercepts, it's really easy to graph because you just plot your 2 points and then connect them with a line. So here we're going to estimate the x and y intercepts. And all the problems here are pretty much designed so that they're going to be whole numbers, and it's going to be the same thing on Connect Math, is that you're not going to get weird decimals or anything when you're estimating. So you're just looking at where we're hitting on the x and then where we hit on the y. So I usually do the x first, and so we cross the x-axis right there at 1. So our x-intercept has an x value of 1. And we write it as an ordered pair, 1, 0, because the y value is 0 at that point. Then the y-intercept, so I need to see where do I cross the y-axis. So that is right here, and you can see that's at -2 according to the graph. So the y value is -2. So y is always vertical, x is always horizontal. And so that's at -2 because that middle point, the center is 0. So we write this as an ordered pair. It's always alphabetical order x comma y. the x value is 0 because it's in the center of the x, and then our y value is -2. So when we give intercepts, we give them as ordered pairs. So you may solve for x or for y, but your answer is an ordered pair because it's an actual point on the graph. It's not just like a single number. So if we look at the one on the right, and I'll do this in a different color. So we have the x-intercept and the y-intercept. So x, we're looking where on the horizontal we cross. So I just put a circle there, and that's at -1. You can see that label there. So x is equal to -1. So our ordered pair is -1, 0, because we're in the middle of the y line, so we're at 0 on y. Then the y-intercept is right here, which is at -3. So y is at -3, and so x is 0, and then y is -3. So our x-intercept is -1, 0. The y-intercept is 0, -3. Are there any questions on either of these two examples? Okay, so here's a couple more. So I will go with the one on the left, the x-intercept, y-intercept. And the nice thing is that if your graph is labeled, if you have every mark on your graph labeled, all you have to do is read the number at where it crosses. And then you have to look, am I on the x or am I on the y? So on the x, we're right here at 3. So x is equal to 3, and this gives us the order pair 3, 0, since y is 0. And then on the y, we cross at 1, so y is equal to 1, and the x is 0, so this is going to be 0, 1. Then on the right, so if I look on my x, it is almost off the graph. It's right to the left there at -4. So our x-intercept is at -4, so x equals -4. And it was ordered pair, that's -4, 0. And then the y here is at 1. So our y-intercept is at a y equals 1, which gives us the ordered pair 0, 1, which matches with the other graph. They have the same y-intercept, but the x-intercepts are different, and so the graphs look different. Any questions? Okay. So now we're going to move on to the actual solving where we need to find our x and y intercepts, and then we're going to use these to graph the line. And I've put a blank grid here. That way we can label the grid however we want to make it easier to graph. So I'm going to basically just color code. So for the x-intercept, we want to solve for x, so y is going to be equal to 0. So I'm going to take the equation that we have, 5x plus 2y equals 5. and I'm going to replace y with 0. So we get 5x plus 2 times 0 equals 5. Now 2 times 0 is 0, so that part just kind of disappears. And so we're left with 5x equals 5. So then we're going to solve for x by dividing both sides by 5. And we get x equals 1. So 5 divided by 5 is 1. So our x-intercept is at 1, 0. And so to graph that, so I want to put that somewhere on the graph. And I usually wait to graph until after I've done both intercepts, just because I may end up with a fraction if I solve for the other one. So I want to make sure that it's easy for me to graph. So I'm going to just hold off on graphing that yet. And now I'm going to find the y-intercept. So the y is where your x is equal to 0. So we're going to take that equation, 5x plus 2y equals 5, and I'm going to replace x with 0. And just like the 2 times 0, 5 times 0 is 0, so that basically cancels out. So we're left with 2y equals 5. So we're solving for y, so I need to divide both sides by 2, and we are going to get a fraction here. We're going to get y equals 5 halves. So our y-intercept is going to be 0 for x, and then 5 halves for y. So graphing 5 halves, it's a lot easier to convert that to a decimal when you're graphing, but when you enter your answer, you leave it in fraction form. So if you do 5 divided by 2, that's 2.5. So if we're going to graph, we want to maybe count by 0.5s so that it's easy to graph 2.5. So I'm going to take my empty grid here, and I'm going to every 2, I'm going to count as basically a 1. So that way, halfway between them, the other tick mark is going to be a 0.5. So it makes it easier to count by 0.5s. And so I'm going to do the same thing in both directions. So I'm just labeling, and then I'm going to go in the negative direction. And I'm going to make sure that I line these up nicely. And then we're going to go down. Make sure I don't skip any. And so now I've labeled, I'm basically counting every other tick mark as 1, so I can do that 0.5. So now I'm going to graph. So our x-intercept was 1, so I'm going to cross at 1. And then the y-intercept was at 5 halves, which is 2.5. So that's going to be halfway between the 2 and the 3. And then to graph it, I just connect those 2 dots. So I've got a little ruler here that I'm putting on top of my computer to try to get it through the dots. It's not perfect, but you connect them, and then now you've just graphed that line. So this is a really easy way to graph lines. If you're given an equation and you're told to graph, it's really easy to graph by finding x and y intercepts, because it's easy to solve for x and y intercepts, because basically you make one of the variables disappear and then you just solve for the other one. Are there any questions? Okay, so let's do another one. We have 4x minus 3y equals -9. So we'll start by finding the x-intercept. And that is where y is equal to 0. So I have 4x minus 3 times 0 equals -9. So the 3 times 0, that just disappears. And we have 4x equals -9. And then I'm going to divide both sides by 4. And I get a fraction -9/4, which as our ordered pair, it's going to be -9/4, 0 for our x-intercept. Now for graphing purposes, it's a lot easier to make that a decimal. So -9/4 is the same as -2.25. So I'm just going to make a little note of that because it will make my life easier when I'm trying to graph. But my answer for the x-intercept is in fraction form. So next is the y-intercept, and that is where x is equal to 0. So I have 4 times 0 minus 3y equals -9. So the 4 times 0 just cancels out, that's 0. So we get -3y equals -9. So I just need to divide both sides by -3. And this will give me y equals a +3. So the ordered pair is going to be 0, 3 as my y-intercept. So now I need to graph this. Now the nice thing about graphing this in Connect Math is that it's already going to label the graph for you, and then you just have to kind of estimate or type in the ordered pair and it will graph it for you. Here, we just have a blank graph, so we have to figure out what are we going to count by. So if I thought, okay, let's count by 0.25s for each tick mark. In order, that means there's 4 marks in order to get to 1 because I'm dividing by 4. I'm doing the fourth for the 4 for the fraction. And I have to be able to graph a y value of 3. So that means if I'm dividing into 4 tick marks for each thing, then I need 12, because I need to do 4 times 3. I need 12 tick marks to be able to graph 3 on the y. So I'm just going to count and see how many tick marks I have on the y going up and see if I have 12. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I don't have enough tick marks here to count by 0.25 because I would need 12 tick marks and I have 11. So maybe instead of splitting it up by 0.25, we count by 1/2 again, like we did on the previous one. So then I need 2 tick marks for each one, so I only need to have 6 total to be able to graph 3. So I'm going to divide that. I'm going to use the same scale that I did on the previous one. I'm going to count every other one. That way I have enough room to graph everything, and I don't have to try to squeeze a 0.25 in these tiny little divisions. So I'm going to label everything again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we got negatives. -1, -2, -3, -4, -5, then -1, -2, -3, -4, -5. So now I'm going to graph for my x-intercept, negative 9/4 divided by 0, which is negative 2.25. So I need to go between the negative 2 and the negative 3. And halfway between there is negative 2.5. So negative 2.25 is halfway between that. So that's about right here. We're going to just kind of estimate it and put it as close as we can. So that's our x-intercept. And then the y-intercept is 0, 3. So I'm going to go to 3 on the y. And now I connect these two dots to get to my line, because whenever you graph a line, you only need 2 ordered pairs. Oh, that was a really bad line. I was trying to use my ruler, and I totally missed. Using a ruler on a computer screen is not easy. I got close enough. So I didn't exactly go through the 3, but I got close enough for our purposes. You get an idea of the shape of the graph. Are there any questions? Okay. So here's another example, but this time our equation doesn't have x and y on the same side. So when x and y are on the same side, it's really easy to find the x and y intercepts. When they're not on the same side, we actually have a bit more work to do than we would normally. So we will start with the x-intercept. And that is where y is equal to 0. So I'm replacing y with 0. So I get the equation 0 equals negative 3/4 x plus 2. So we're solving for x. So I can either subtract 2 from both sides, or I can add 3/4 x to both sides, because the left side is 0. I'm personally, I like to have a positive, so I'm going to add the 3/4 x to both sides so that I have a positive on the left. So we have to actually move it, and that gives us 3/4 x equals 2. So now we're solving this equation for x, and we have 3/4. And when we want to get rid of the 3/4, when you have a fraction, you'd be dividing by a fraction, which is the same as multiplying by the reciprocal. So we're going to multiply both sides by 4/3. So I like to do this in a different color. And so that means on the left, the 4/3 and 3/4 cancel. We get x equals. And then on the right, you multiply the whole number by the top of the fraction. So that's going to give us 8/3. So our x-intercept is 8/3, 0. So now we're going to find the y-intercept. And when you've got x and y on opposite sides, and when it's in particular, it's solved for y like it is now, it's a lot easier to find the y-intercept. So that's where x is equal to 0. So I have y equals negative 3/4 times 0 plus 2. So the 3/4 times 0, that cancels out, and then we're left with y equals 2. So that was nice and easy. The x took some work, but finding the y was pretty simple. So the y-intercept is x first, so that's 0, and then y 0, 2. So now to figure out how to graph this. So I have a fraction, so I might want to count by 3s. So if I count by 3s, in order to graph a whole number of 2, 3 times 2 is 6. I need 6 tick marks. And we've established that we have 11 tick marks. So I'm going to count by 3s, and that will make it a lot easier to graph something that's 1/3. So every third is going to be a whole number. So I'm just changing how I'm making my graph and counting on my tick marks to make it easier for me when I'm trying to plot my points. You don't always have to make every tick mark a 1. So every third one is a whole number. And then I make sure that I label all of these. Even if I'm not using one of the directions, I label them all because it just makes it a lot easier. So the negatives are to the left and down. So our x-intercept is at 8/3. So I'm going to convert that to a decimal. And that is 2.67, or it's about 2 2/3. So I'm going to go to 2, and then 2 more tick marks will get me 2 2/3. So that's 8/3. So sometimes it's helpful to make it a mixed number. And then I need to graph 0, 2. So that's nice because I just have 2 labeled on my y. And then I just need to connect these. Oops. I'm knocking everything over as I try to put my ruler on my monitor. Are there any questions? All right, so we'll go to the next one. So this is another one where it's solved for x and or it's solved for y. And so we're going to have to do a little more work to get the x-intercept, but then the y-intercept will be really easy. So the x-intercept, oops, it would help if I spelled this right. So where y is equal to 0, so we have 0 equals to 2/3 x minus 1. So I want to solve for x, and in this case I think I'm going to add 1 to both sides so that I have positive values, and instead of moving the x, because if I move the x I'm going to have to subtract and then I'll have negatives. So this will give me 1 equals 2/3 x. So we want to solve for x. And with a fraction, you want to multiply by the reciprocal. So we're going to multiply by 3/2. And the 3/2 and the 2/3 will cancel out, and we get 3/2 equals x. So our x-intercept is 3/2, comma 0. Next is the y-intercept. So that is where x is equal to 0. And notice how I'm taking notes and how I'm writing this down. I keep putting in parentheses what's 0, and that will help you remember. And also when you go into notes, you'll see, oh, okay, y is 0 or x is 0 when you're trying to find these. So for the y-intercept, x is equal to 0. So we have y equals 2/3 times 0 minus 1. So the 2/3 times 0 is 0. And this gives us y equals -1. So it's x is 0. So it's 0, comma, -1 for our ordered pair. So you want to make sure for your intercepts the numbers are in opposite positions here. So I want to now graph these, and because I have 3/2, that's 1 1/2. I should have plenty of tick marks if I count by halves. So every 2 is going to be a whole number. So I'm just going to label these. It's a lot easier in Connect Math when they give you the graph. You don't have to make your own graphs. I have to make sure I'm counting correctly for all of these. So 3/2 is 1 1/2. So for the x-intercept, that's halfway between 1 and 2. And then my y-intercept is at -1. So I'm going to put that dot there. And then I need to connect these. And I think I just nope, I thought I almost, oh, I did accidentally exit my, I accidentally pushed a button when I was trying to get to the grid. Okay. Oop. Oh, I've got to turn on the pen again. There we go. Okay, so again, I'm not exactly going through my dots, but it's close enough for our purposes to kind of show you what the graph is looking like. Any questions? Okay, I think I'm going to skip my next one because that's sort of the same style. Let's do this one. So we're finding the x and y intercepts, and we've got -3x plus y equals 0. So same thing as what we've been doing. We find the x-intercept first, which is where y is equal to 0. So -3x plus 0 equals 0. When you replace y with 0, it's just 0. And so this gives us 3x equals 0. So I see a lot of people making a mistake here because then they want to say x is equal to 0 or x equals 1, and I've seen some various things. So, or I've seen people say x equals -3. So we're dividing both sides by -3. And 0 divided by anything is 0. So we're going to get x equals 0 here. So this is always interesting for people because for our x-intercept, x is equal to 0, but then the y is also equal to 0. So we get the origin. We get the middle of the graph. If you have both x and y 0, which if you get the origin, then this point is both an x and y intercept. So origin 0, 0 is both x and y intercept. So if you, and you could test that out. If you solve for the x or for the y intercept, x would be equal to 0, you get y equals 0. So we get only one point here. We can't graph a line with only one point. So we need to pick another point, and either another x or another y, any number that we want to plug in so we can get a second point to graph. Because if you have 0, 0 as your only intercept, and this is a special case where you have a line with one intercept just because it's going through the middle, you don't know where the line is going without a second point. So we have to actually make a table of values here. So I'm going to, right now with our table of values, we have x and y is 0. And then you need to pick a number to plug in. So you can pick a number for x or a number for y. It doesn't matter. Because on our equation we have y by itself without any number in front of it, I will pick an x value because it will be easy to solve for y. We don't have to divide by anything. And it's really easy to pick 1. So we're going to say, okay, I'm going to decide that x is equal to 1, and then what is y? So I'm going to plug this into my equation. So we have -3 times 1 plus y equals 0. So -3 times 1 is -3. So we have -3 plus y equals 0. And now I need to solve for y And I'm going to move the 3 so that I don't have negatives to deal with. So I'm going to add 3 to both sides. And so that gives us y is equal to 3. So now I have a second point to graph. 1, 3. So I need to label my graph, and so we can just count by ones. That's easy enough. These are really small, so I'm just going to kind of label the first 2 because there's really not a lot of room here. But if we count each thing by 1, because we can, then my second one is going to be 1 on the x and then 3 on the y. So I'm going to go over to the right one. Oops, just dropped my ruler. And then up 3 to get up to y equals 3. You always start at the center. And so that's our second point. It's not an x or y intercept. It's just a second value on the line that we can use so that we can connect these. So now I'm going to attempt to draw my line through it. Again, not the best line. It's probably better if I tried to eyeball it rather than use a ruler. But that's what this looks like. And this is a special case where you have a 1 intercept and it's both the x and the y intercept. So I'll just kind of indicate that this is a special case, because most of the time a slanted line has 1x, 1y. They're not the same point. Here they're the same exact point. Are there any questions? Okay, so I've got one more example here. We've got some larger numbers here. I thought that would be a good thing to do. So we've got 20x equals negative 40y plus 200. So we will start by finding the x-intercept. And that is where y is equal to 0. So I have 20x equals negative 40 times 0 plus 200. So negative 40 times 0 is 0. And that cancels out, so I'm left with 20x equals 200. So I'm going to divide both sides by 20. And we get x is equal to 10. So our x-intercept is 10, 0. Next, we want to find the y-intercept. So x is equal to 0. So I'm going to have 20 times 0 equals negative 40y plus 200. So 20 times 0 is 0. So we have to write 0 on the left, equals negative 40y plus 200. So to solve for y, I'm going to put the y on the left so I have a positive 40y. So I'm going to add 40y to both sides. So we get 40y equals 200. And then we're going to divide both sides by 40. And I believe that gives us 50. Y equals 50. I'm going to double check on my calculator just to make sure I'm not doing a math error. Oh, 5. Good thing I double checked. I was off by 1 on my zeros there. So y is equal to 5. So our y-intercept is then 0, 5. So I can count by ones here. I know that I have 11 tick marks. So if I have to count by ones, and that can get me enough to count up so I can get to 10. So I'm going to count by ones. And I'm going to just label the first couple. It's a 1 right there. So let's just assume that we count by 1. So the x-intercept is at 10, 0. So I need to count 10 tick marks. And that puts me right here. And then on the y, it's at 0, 5. So I need to count 5 going up. 1, 2, 3, 4, 5. And then I connect those in order to get to my graph. Oh, that was not too bad. That was a pretty good one. And so that's what our line looks like. So we found our x and y intercepts. You've seen how to graph using those. Do you have any questions? Okay, so that's all I had for today. It did look like we had a lot of people that tried to join and then kept leaving. So I don't know if there was connection issues, because we had 3 or 4 people that just kept coming on and off. So strange. I don't know if people are having internet problems or something, but you know, of course, since this is recorded, they'll get to see that. So thank you for joining me live today. I appreciate it. Hopefully this was helpful. And next week, Saturday, we have our last one, because that's week 8. So we're almost done with class. All right, so enjoy your Saturday, the rest of your day, and I will talk to you later. Bye.